In this video, we'll look at some of the key features of functions given a graph. If you look at the screen, you'll notice some of the terms: continuous and discrete, intervals where it's increasing or decreasing, minimum and maximum values, domain and range, as well as x and y intercepts. Let's begin by looking at the ideas of continuous versus discrete. Continuous means that if I put my pencil on the graph and trace along the graph, I can move throughout the entire function without ever having to pick my pencil up. A discrete graph would be just points. Sometimes the graph is neither continuous nor discrete. In that case, you would have to pick your pencil up to move once you've gone to a certain number of points, put it back down, and then trace out again. We would call that neither continuous nor discrete, or sometimes we'd call it discontinuous. This graph is an example of a continuous graph. Intervals of increasing values is where you have positive slopes. This graph has two places of positive slopes. One of them is right here. This interval begins increasing where x is -3. When you write the intervals, we're going to use the x values because this graph is a function of x. Therefore, we use the x's to describe what's happening. X equals -3 is the first place where this graph begins increasing. We'll use a closed bracket to indicate that -3 is one of the points where it begins increasing. Now it's going to continue increasing to where x is 1. At this point, it stops increasing. So we will use an open bracket, or open parentheses. There's another spot where the graph is also increasing, and that's over here. This begins increasing where x is 3, and will continue all the way towards infinity. It will continue to go to the right. However, you cannot get to infinity, so when we write this, we're going to use the open parentheses, indicating that it actually never gets to infinity. For intervals decreasing, the first one is on the far left-hand side. Beginning where x is -6 and continuing to where x is -3. It stops doing that, so we'll use the parentheses indicating that's where it ends. The next interval of decreasing begins where x is 1 and continues to where x is 3. So to write that, it goes from where x is 1 and continues and stops at where x is 3. For the next part, the minimums, we're going to basically look at where the graph goes the lowest on the value. There are no arrows going down indicating that there will be a minimum value. If I look at it, the minimum value is down here. It's where y is equal to -2. So when I write that, I'll put y equals -2. Okay. Personally, I prefer that you do not write it as a coordinate. If you write the coordinate -3, -2, it begins to look like an interval, and that sometimes confuses people. I like it better if you just say what the y value is. For the maximum, this graph has an arrow heading up. This tells me this graph will forever head up. Therefore, it cannot have a maximum. It'll approach infinity, but will never make it there. So therefore, when we write the answer, we'll say there is no maximum. All right, headed to the left-hand side now. Now we're going to look at the domain of this graph. The domain is what the graph does from left to right. It's the x values. So looking at this graph, I see that there is a closed dot on the far left-hand side. The arrow on the right-hand side indicates the graph goes forever to the right. So when I say the domain, it begins where x is -6. It's a closed dot, so we'll use the bracket, and continues as x approaches infinity. We'll use the open parentheses indicating that it actually never gets there. This is known as interval notation. Sometimes we'll use set builder notation, which would look like this. It's the set of x such that x is greater than or equal to -6. Sometimes it's also written like this. The set of x such that x is greater than or equal to -6, but less than infinity. For the range, now we're looking what the graph does up and down. That's the y values. This graph has no arrow going down. It does have an arrow going up, so we know it'll be approaching infinity. The lowest value, if we look at our minimum, was -2. So using set builder notation, we would write something like this. It's the set of y such that y is greater than or equal to -2. In interval notation, it would be this. It goes from -2 approaching infinity. Now we'll turn our attention to the intercepts. The x-intercepts refer to where the graph crosses the x-axis. Remember, the x-axis is the horizontal one. This graph intersects the x-axis in 2 points. Once here, and then again over here. When you write the intercepts, it's important to put it in coordinate form. I see that the graph crosses where x is negative 4. However, there's lots of possible values where x can be negative 4. All x-intercepts should be written in the form of something comma 0. This is because along the x-axis, y is always 0. When I write this, the first point where it's going to cross is at negative 4, 0. The second coordinate where it crosses is at negative 1, 0. Again, these are points, they're not intervals. This just tells me at negative 4, 0, the graph intersects the x-axis. It does it again where x is negative 1, 0. Turning our attention to the y-axis. The y-axis is the one that runs vertical. If I highlight it, it's this one here. This graph intersects the y-axis in 1 point. It does so when y equals 1. Any y-intercept should be written in the form as 0, comma something. The 0 in the front indicates that the x value is 0 because that's where the y-axis is. When I write this, I'll say it's the point 0, comma 1. I hope this helps you to understand some of the key features of functions. Thank you for watching.